Hey everybody, welcome to video 39. Today we're going to be looking at your taste and smell as senses. So this is going to be everything that has to do with the tongue and your oral cavity, as well as olfaction in the nasal cavity. Starting off with taste, the more scientific name for taste is gustation. Gustation can be broken down into its four subtypes. Think in an earlier video we talked about the different types of touch. You can do the same thing with gustation. So you have salty, sweet, sour, and bitter, plus one that was recently identified in the 1980s, umami, which is going to be, think of it like a savory taste. There are some studies out there that are beginning to show that there may even be a sixth taste. And that's going to be that for being able to taste lipids. Not exactly sure if there's really a difference in savory. Usually if you're tasting something savory, it's something like meat, which already has plenty of lipids with the proteins. So I'm not exactly sure how they are separating those, but who knows? Maybe there is a separate taste to be able to taste butter. But your oral cavity is lined with stratified squamous epithelia. Remember, stratified is going to mean many layers. Squamous, they're going to be squashed flat. And on your tongue, you're going to have some raised bumps known as papillae. Now, those papillae are going to have taste buds on them, which are the gustatory receptors of those taste buds. They're going to be sensing chemicals in your food, meaning that they are chemoreceptors. The stronger the taste, the stronger the stimuli for whatever they are chemically sensing, they're going to release more neurotransmitters to communicate to the rest of your nervous system that this is a stronger taste. When you're tasting something salty, your chemoreceptors are going to be noticing that there are more sodium ions in your food. Now, table salt for us is made of sodium chloride, and usually if sodium chloride is dissolved in something, the sodium ions and the chlorine ions are going to separate. But when we are tasting something salty, we are noticing all of those sodium ions. If we're tasting something sour, actually what we're tasting is the acidity of something, so how acidic something is. The more hydrogen ions there is, the more sour that food is going to be. Because acid is all based around how many hydrogen ions there are. So, more hydrogen ions, the more sour your food is. Sweet taste is going to be based on how much glucose is in your food. Although with all the artificial sweeteners we have, we figured out how to make something taste sweet and not include all of the calories associated with glucose, those 4 calories per gram associated with carbohydrates. But what we're doing is we're taking advantage of those same chemical pathways to those chemoreceptors that sense glucose, and we're giving them a molecule that's similar enough to glucose that it goes ahead and stimulates them anyways. Bitter taste can be due to a number of different things. Most commonly, it's going to be due to the perception of alkaloids, which is just a chemical molecule that contains nitrogen. In fact, though, alkaloids at a high enough level can be toxic to the human body. So that's why alkaloid water used to be a major danger back in the 1800s, something that you wanted to make sure your water was not too low or too high, of a pH. Umami taste is going to be the sense of a very specific amino acid known as L-glutamate. Umami, again, is that savory taste, which is going to be associated with your proteins, which makes sense that then this is the perception of an amino acid, where amino acids, you may remember, are chains of amino acids make proteins. So here you can see your tongue in the stratified squamous epithelia. It is important that it is stratified squamous. Think how many times you burn your tongue. When you burn your tongue, you're going to kill those cells that are most superficial. But because it's stratified squamous, you're able to shed those cells and let new cells move up from deeper, from underneath. You can see all these different papillae. We aren't going to worry about them, but you have these taste buds, these taste hairs in some cases to be able to catch the chemicals for whatever we are sensing, be it hydrogen ions, be it sodium ions, whatever it might be. And then that is what's going to stimulate the action potential to begin in these gustatory cells. When it comes to smell or olfaction, it's going to be very associated with taste because actually you're going to have a lot of odorant molecules that might get pushed up from your oral cavity into the nasal cavity. And so that's why taste and smell are so closely linked, is oftentimes you're smelling something at the same time you are tasting it. Odorant molecules are going to become trapped in mucus that is lining your nasal cavity. And that mucus is then going to transport those molecules to bipolar olfactory receptors. From there, axons are going to travel through a foramen in your ethmoid bone to the olfactory bulb before they end up splitting and going to different areas of the cerebrum depending on what that smell is associated with. But because it's able to go to many different areas in your cerebrum, senses of smell can be a very powerful trigger of memories. They might pass through that thalamus, pass through that hypothalamus, and become associated with a lot of things with memory. So here's a little bit better example. So this would be like the top of your nasal cavity. You can see the inset being drawn out here. And so air is coming through, passing through your nasal cavity. Different molecules that you have in the air will become trapped in the mucus. So if you're eating things like pizza, you're going to have different chemicals coming off of whatever spices are in that pizza, whatever you have for cheese, whatever you have for a crust. All sorts of different molecules are going to be coming off that and becoming stuck in the mucus. And then they travel up until they stimulate your olfactory receptors here, which are then going to travel through the ethmoid bone and through this foramen here up to the olfactory tract, and so they can be sent to the brain. If any of you have ever watched the movie Black Widow, there's a scene where it's all about breaking apart that nerve. And so what they're doing in that case is they are causing a fracture in the nasal and the ethmoid bones to the point where any sort of movement in this ethmoid bone will end up shearing these olfactory receptors here to where they're no longer able to carry that action potential to the brain, and you lose your sense of smell. So that is some discussion on how taste and smell work. We see a lot of things with chemoreceptors here for taste and smell, so that's why they're also very closely linked. Not only do they often happen at the same time, but they're using many of the same type of receptors. So, as always, if you have any questions, please let me know, either in class or on Schoology.